Okay, so marking inequalities. Now, just as a quick, if we were asked to, for example, solve 5 plus 2x is greater than 7, if we were to solve that, what would we do?
7 minus 5
Now x does not equal 1. Okay, x is greater than 1. Yes? Yeah?
Does the sign not flip?
Now the sign only flips if, for example, this had been minus and we would have to divide by -2. So if we're dividing by -2 at that point, that's when that changes. Okay? So that's only when there's a negative sign in front of the x. Okay, but anything else about it stays as it would do as if it were an equation. Okay, but if you're solving an inequality, treat it as though it was an equation, but keep the inequality sign there. Okay, so we'll all remember that, yes? I'm hoping that if you're asked to display x is greater than or equal to 2 on a number line, this has been covered, but I don't know if you remember it. No? Anyone?
With the arrow.
Yes, with the arrow thing. So you might have 0, 1, 2, 3, 4. We're showing greater than or equal to 2.
You have a little like dot over the two?
Yes. Is it open or closed? Closed, why closed?
So this equal to.
Yep. And then what do we do to show greater than? Just like that, yes? So vaguely remember? If we had -3 is less than x is less than or equal to 1. Okay, so remember that is telling me I've got a range. So -4, -3, -2, -1, 0, 1. Okay, so what kind of thing would I have above the 3? Open hole, above the 1, closed hole, and between them. Yes? Is that all
Why is it above the there and because 2 and above? Who? Yeah. Oh, what's showing what
It doesn't greater than 10 GB, but
yeah.
yeah, I did choose that too for the back.
Okay. Do we is it a legit appointment?
Yeah.
Okay. Not yet parental information you're leaving for. Do you not? I haven't even then. No. Maybe something was at your form teacher? Who knows? Okay, lovely stories. Right, so we vaguely remember this stuff, yes? Yes. Kind of flooding back to us. If we had something like this and we're asked to, and we're told that the number is an integer, which values would satisfy this? If it was an integer that satisfies this range, what values would you have? What values would you list? Okay, are we all happy with that? So if it was an integer, we know that means it's a whole number. We can't include -3 because it has to be more than -3. So -2 is the first one, but we can include 1 because it's got the or equal to. Yes? Right, so that's a recap of those kinds of things. Now we come to actually graphing inequalities. These are quite common. They connect the drawing straight lines, which everybody loves, with inequalities. So we need to remember how to draw any straight line. How should we rearrange it if we want to draw a straight line graph? What form should it be? Okay, lovely jubbly. In order to draw the line, the inequality sign can be taken as an equal sign, and then we just need to shade the correct sign. If the sign that we have in the inequality is greater than or less than, then you draw a dotted line. If it's got the or equal to, it would have a solid line. Now, if I'm honest, they are not as strict about the dotted and solid lines as they might be. So don't panic too much, especially because your instinct is going to be to draw a solid line, because that's how you just grab your ruler pencil and draw it. And then it's too late, you can't make it dotted once it's already solid. So don't panic too much about the solid and dotted, but officially if it was this sign here, it should be dotted, and if it's one of these, it would be solid. Right, so how do we do that? Well, the gradient y-intercept method, you find the y-intercept, because that's the value of, in here, what's the C, and the gradient would be represented by M. Okay, remember that's rise over run. Okay, so it needs to be a whole number, not whole number, it needs to be in fraction format, so you've got the rise and your run. Okay, so that's lovely jubbly, we've recalled that. So, here we go, we need to shade the region represented by x plus y is less than 4. So first of all, we're going to rearrange that so it says it's in the y equals format. So in other words, the y is on its own. So how would I do that? What would it become? 4 minus x. Okay. So what's my y-intercept? Anyone? 4. Okay, so I'm just checking. I know some people are not fully paying attention. So our y-intercept here is 4. And what's our gradient?
1 over 1.
Careful. Negative 1 over 1. Yes? Okay, so here's our gradient, our secret 1. And here's our y-intercept.
Why is it negative?
Since it's negative.
Okay. Why is it over 1?
Because it's always better to have rise over 1. So even if it's when it's a whole number, just stick it over 1. Yeah? Right, so we need to draw that line, first of all. And it's this symbol here, so it ideally would be dotted, but let's just give it a bash. So we need to put some numbers in our scale. I'm just going to label 2, 4, 6, 8. Oh, ow, shoulder. -2, -4. I'm going to do this, 1, 2, 3, 4, because this happens quite a lot in the real thing, and lots of you mess up when I've seen this. Okay, so I have a different scale on my x-axis and my y-axis. Okay, that does often happen. So if I was drawing that line, I would start at my gradient, my y-intercept, which is at 4. And my gradient is -1. So that means from that point, I'm going to go down 1 unit and across 1 unit, not 1 square, 1 unit. So I've gone down 1 unit, across 1 unit, and I get here. It's -1, isn't it? And +4? Yeah. So I'm going down 1 unit, across 1 unit, and I get to that point. Remember, 3 points is always ideal if you're drawing a straight line. Now, are there people sitting here thinking, what the heck is she doing? Where did she get those things from? So now, help me out. What bit? Where did I lose you?
Where do you get the green X from the question?
From the y-intercept here. Okay, it's the whole number. It's not the thing not with no x attached to it. Okay? So if there was no number, if it was just x's, then it would be a 0. So you would start at the origin. You're happy with the -1?
Yeah.
Tanya?
Can you scroll down for a second? Why do you go down 1, but then you go up?
Okay, because I was saying very clearly, we go down 1 unit across 1 unit.
It doesn't go from 4 to 2, it just goes 4 to 3. Which one makes it 3 better?
I've labelled mine every 2. I just so happen to label it every 2. Yes? I could have labelled 1, 2, 3, 5. Yeah? But as I said, it's common for them to have different scales, and you lot haven't been very good in the past when I've been looking through questions, spotting that they have different scales. So because I need to go across 1 unit, you've just gone down across 1 square, because that's in your head what you've always had. Okay? So please, 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 please check your scales. Now I'm going to join that up. Okay, now as I said, because it was that symbol, I should be having a dotted line. Okay, if you've already gone solid and you're in pen, you can't do anything about it. If you've gone solid in pencil, you can do some erasing marks to make it dotted. as I said, don't panic too much. I don't want anyone coming out in tears saying, oh gosh, my line was solid. Okay, do not stress. And just extend a decent amount. Okay, don't do a tiny baby portion, just extend the whole amount. Okay? Right, but this is shading inequalities. So what we have to do now is we have to decide which side they're interested in. Now, this is the tricky thing. You will find some textbooks and some people say you shade the bit that you do want. You get some people and some textbooks that say shade the bit you don't want. Okay? Majority of the time, the questions are going to get you to have several areas, and they form some kind of shape, often a triangle because it's often 3 areas, and they want you to label it with a letter. Okay, so whether you've chosen to shade the bit you want or the bit you don't want, as long as you're putting the label in the correct side, you're okay. Both make sense. To shade the bit that you're not interested in and leave the bit that you're wanting free and clear. Lovely. Shading the bit shows you that you're interested in that bit. Okay, so neither is better nor worse, but anyway, it can be a tricky situation. All right, so we want to shade where y is less than 4 minus x. The best way of doing this is to say, right, here's our line, obviously. We've either got this side or this side. I would select a coordinate or a point on one side of the line. So I'm going to choose this point here of 0, 0. Okay?
So one point of the what line? The dotted line, right?
One side of the dotted line. Yes? Now, I've chosen that point there because that's nice and easy to substitute in. And you don't have to do a lot of calculations with the 0, 0.
But
Okay?
it can be any spot.
It can be any place. Do not choose something that sits on the line though, okay? Because that's not going to be of any use to man or beast. Okay? So then what we do is we say, right, y is less than 4 minus x. We're going to decide, is this coordinate on the area we want or not? So we're going to then substitute the coordinate 0, 0 in place of my y and x. So we say 0 is less than 4 minus 0. 0 is less than 4. Is 0 less than 4? True. Okay? Now, this is where you say, do I want to shade the bit I want or the bit I don't want? Okay? Have I suggested what we want to do here? No. So what's your gut instinct wanting to do? Do you want to shade the bit that's true or the bit that's not true? The bit that's true. Okay, so that would mean that we would then shade this side of the line, or we would show that this bottom part of the line is the bit we're interested in. That should mean that any coordinate we chose on this side of the line would satisfy this equation, this inequality. That all of our y values are going to be less than 4 minus x. Okay? Because that's what we've done. Now, I've only shaded a little chunk of it. You can shade the whole thing if you love shading.
But you're supposed to shade the...
What, you can shade as much as you want, just as long as you've indicated which side of the line it is. Okay? But as I said, it does get a bit confusing because people are like, well, so-and-so teacher told them to shade the other bit. You'll find in textbooks, in worksheets, online, everywhere is different. Okay, so this is what I mean. And what tends to happen is they'll say, right, you need to shade 3 inequalities. So you're going to have this line, and this line, okay? And then I'm guessing it's obvious that you're interested in this portion here, which is what you label as R. So they will give you several, and they tend to give you a letter to shade it. So if you had that situation, you may have shaded outside here, and labeled that bit R. Okay, either way, as long as you're representing the correct area with the letter, you're fine. Okay? So in our case, if we'd been asked to shade label it R, we would have written R on this side. Yeah, does that make sense? Now I think all the words at the bottom, we've kind of gone through the process at the top, we just haven't put them in the right place.
Do you not have to do the other side of the line?
No, because we're just identifying one side of it.
Shade the region representing
Yeah.
okay. Then you should any kind of point
On either side of the line. On either side of the line. Okay, let me show you.
costume.
Yeah, this will be.
Then you shade the side that's
Okay, so let me. What this? I don't know how to tell them it's
yeah, or the side that's not true.
Yeah. Okay, so sometimes it's true, sometimes it's not true.
Wait, why would it be either side? Wouldn't it be the side that?
But this is what I mean. It's. Some people say you identify the side that you're interested in, and that means shade the bit you don't want. Okay, so shading is tricky. Like if we're shading the bit we do want, if you're identifying it, they might say, well, I've crossed out the bit I don't want by shading it. Okay, so it's all in a little bit of a grey zone.
But how far does your shading go down?
It doesn't have to go down very far at all. You could have literally just done a little bit here. That would have been enough because we've shaded the correct side. Now, just to clarify, if I had chosen this coordinate here, this is the coordinate 2, 6. Okay? When I substitute those numbers in, 6 is less than 4 minus 2, 6 is less than 2. Well, that's not true. That's why we didn't shade that side. Okay?
Oh, so you could choose any coordinate.
Yes, so that's what I'm saying.
Ah,
Yeah.
6 is more than 2.
So because
I don't know
that's
if that's
not...
true or not then. It's not.
Oh, whoa, I don't know how to
Oh, you
answer
mean
that.
literally like 6 is more than 2.
Yeah.
And the next one is 0 is less than 2. Okay, I think it was actually. Alright, have a nice weekend. I thought you were going to say weekend.
She was.
She was.
So Emma, we've established how we know whether 6 is more than 2 or not. Okay. There are some things at this point I can't help you with. Like that's yes, it just is clear behind. Okay, now some occasions you're asked to identify the region, so you may be required to shade or not shade. So just be aware. Now, these ones, remember if there's just a Y and a number, you've got to decide is it a vertical or horizontal line. So for when it's a Y and a number, what kind of line is it?
Horizontal.
Was that 50-50?
Vertical.
Oh, we've got both in.
There's a Y and
Oh wow, Natalia, it's getting aggressive now.
It's horizontal.
It is horizontal. What'd you say? This is what I want to do because I want you to be as aggressive as Natalia was and go, it's horizontal!
Why would it be horizontal though?
Oh god.
Then it's horizontal. If it was vertical.
Okay, we learned.
If it was vertical, it would be X.
We learned that any horizontal line is with Y and a number.
Yeah.
Any vertical line is X and a number.
Okay.
Yeah? We did learn that, I promise. So if we're identifying Y is greater than or equal to -4, we're going to draw the line Y is equal to -4. And this one's time it's going to be solid. I'm just going to go -2, -4. So this one's a solid line at -4. And again, you can shade either side if you want to identify it. You can say region, maybe you would say region R up here. We've identified it, you might shade not this bit.
It says to shade what does not satisfy.
Okay, so we would shade down there, like but what I'm trying to get with these notes is that it could be any of these options.
Wait, the dotted line is if it's not.
Correct. But we're getting the idea, yes? So essentially we've got a line once we've drawn our line, we need to decide, is it on the left side or right side? Is it above it, below it, whatever?
So, how did you decide for this one? So not satisfying.
Because y has to be greater than or equal to -4. So the numbers where y is greater than or equal to -4 are all of these numbers up here. Yeah.
So we should change that. We should change that.
Well, on this example, I've suggested that we shade that we don't want. This was -4. I just knew all of these numbers were bigger than -4.
Oh, that is some side that is not bigger than
Yeah.
-6.
So I've shaded below it.
But below it is bigger than.
So you
Oh,
put
it's
this
smaller.
number.
Yeah. So you can take above or below.
Just be careful if they've asked for a letter to show which area, which side.
Well, it's the thing where you choose the point though and then substitute it.
Okay, we can choose a point here, this point here. This is the coordinate -2. -2, 4. And what's the value of y in this coordinate? Is that greater than or less than?
Greater than.
Greater than, so that's the area we're in.
So just choose any side.
Okay? Actually, try and not to tick tock. Let me go there, maybe for 5 seconds.
Wait, what did we do with this one? Sorry, I was shading.
What do we do with what numbers?
-2.
I just said which is the y coordinate. This one, is that greater than or less or equal to -4? Yes, it's greater than, so that's the area. Emma was worrying about substituting coordinates. Like I said, you don't always have to, but if you wanted to, it would work. So. Okay? So identifying one. So sometimes they may give you a diagram and ask you to identify which area has been shaded. Okay? So they want you to identify the shaded area, not the non-shaded area. So the first challenge is to identify the equation of the straight line. Now, these questions may well come up because they haven't had time or been able to ask you a question about straight line graphs. So obviously this topic brings in the concept of inequalities as well as straight line graphs. And establishing what equations are. So if I was to find the equation of this, we're looking for the same features as we did just now when we were drawing them. We want to look to see what's the y-intercept. So what's the value of C?
2.
And what's our value for N? How do we find it from the graph?
2 over
Okay. Yep, so we're finding any 2 points, so I'm going to randomly pick this one and this one. I've gone down 4 units and across 2 units. So that's -2. Okay? You could have picked any 2 points. Lots of people were telling me it was -2 anyway, or 2 over -1. Okay, once I've got those 2 values, how do I make it an equation of a straight line? I just write y equals -2x plus 2. She says, hoping that everyone is thinking, yes, that's obvious.
Yes.
I haven't done anything yet, Natanya, other than establish what the straight line equation is. Okay, so I haven't dealt with the inequality yet. Okay?
Oh, okay, I was wrong.
Alright? Now I need to decide what sign this should be. Okay? They want me to identify the shaded area. So I need to pick a point on the shaded side. Okay? And I'm going to establish what sign would make that true. I like to pick the coordinate 0, 0 because it means it wipes out any kind of multiplying going on. But you don't have to. And as I said, if 0, 0 is on the line, don't ever choose it. But in this case, we could pick it because it's on the shaded side. Okay? So I'm going to say 0. And I'm going to say, I'm leaving this blank just for now. -2 lots of 0 plus 2. Okay, so I've chosen the point 0, 0 and I'm substituting it in. So I've got 0. I'm leaving this blank because I need to establish which sign to put in. Negative 2 lots of 0 plus 2. So 0, leaving it blank. Negative 2 lots of 0 is 0, and then that's 2. Now I'm going to go to my numbers queen, and Emma, is 0 bigger or smaller than 2? See, you were doubting whether you'd be able to work it out. So 0 is less than 2. Okay? So I'm going to put the less than sign in. Am I going to choose the or equal to? No. Well, in this case, look at the kind of line that they've drawn. Is it solid or is it dotted? Solid. So solid lines indicate that it would be or equal to. So when I asked or is it, I know you'd laugh because 0 obviously isn't equal to 2, but in our situation, for our equation of the line, we would have the or equal to symbol. Do you all understand that? So now I'm going to go back to here and say that y is less than or equal to negative 2x plus 2. I have shaded the area that they have displayed. So you find the equation of the line. You then establish whether they want you to identify the shaded part or the non-shaded part, stick a coordinate in, and choose a sign or symbol that makes that statement accurate.
Yeah.
Okay? Now, as I said, often we'd have to have 3 things, and we would be asked to identify a region. 99% of the time, I won't say 99 just because I can't remember any others, but I think pretty much all the questions I've seen end up being a triangle, okay, because they always have 3 areas. So we need to draw these 3 lines. So x is greater than 1. So we're going to draw the line x equals 1. So is that
vertical?
Nice. And it's going to be a solid or dotted?
Dotted.
Dotted. Solid as a rock. That's solid, by the way. Okay, that's my red one. I'm just going to keep going just because I like to extend stuff. I'm now going to draw the line y equals 1. Okay, I'm going to draw this one in blue. We've already established y graphs are horizontal ones, and so that goes through 1. And what kind of line is this?
Horizontal.
And it's dotted. Very bien. We need to do a little bit of work with our next one because it's not in the y equals mx plus c format. So I'm going to have y is less than or equal to 3 minus x. Okay, so I've rearranged that so y is on its own and positive. So I'm starting that graph at where? 3. And I'm going down 1 across 1. Down 1 across 1. So that's down 1 across 1, down 1 across 1. And this one's going to be solid. Oh, that wasn't great.
So you started at 3.
Started at 3 because that was my y-intercept. Oh, Natalia's face is not.
Can you explain the red line again?
It's an x equals 1.
Oh, it's just on the 1. Ha.
It's a small little triangle.
Yeah.
It is a baby triangle. Now, our gut instinct, I hope, would be like, well, surely this baby bit here is R, but just double check that that does satisfy everything. So x has to be greater than 1. So I'm hoping you're all happy that that means on this side of the line. It has to be greater than 1 on the y, so that's talking in this direction. And y has got to be less than 3 minus x, which is on this side. So I'm just going to put this baby in here. and that's R.
The arrows represent what? Sorry.
So this, because y has to be greater than 1, so that means up here.
Okay.
Greater than 1 that way, and it would be less than this way.
What is for the
R for region.
That would shade all of the stuff around.
You could do, and that's the kind of situation. So some people shade the thing and label that R. Some people shade the bits outside to show that that's the bit they've left. But the important thing is just where you put the letter. So the shading isn't so important here. It's where is the letter.
How do you know that it's
On the right side of the diagonal? No.
why is one okay? So the first one's vertical, the second one's horizontal. How do you know the last one's diagonal?
Because it was an x plus y is less than 3. So we did y is less than 3 minus x. We rearranged it to be mx plus c. Yes, we started at 3 because that's our y-intercept. And gradient of -1.
minus 1 over 1.
Minus 1 over 1.
You just did on the x and like you and minus 1 over 1 and then minus 1 over 1. Then you do it.
Yeah.
So
Okay? Oops.
oh wait, but yeah, how do you know that that's the diagonal is going down? Like how do
we know it's over here?
It's a minus.
To me?
No, like you said it's a rectangle. Like how do you know that the line?
Well, there's no way that you're going to have an area enclosed by all 3 lines unless it is on this side.
Okay.
Basically. Okay, but make sure you can do what we just did, take a coordinate on one side of the line and just check it's on this part. Okay. I mean, realistically, I say that. I mean, it could be this area here. Okay, so this bit could be the part that's R, but often it's actually in an enclosed triangle. Okay. Do you have anything else? Oh, let's talk about these another time. Because they're not easy. Okay?